Let us solve this interesting question from November 2018. Straight post tension concrete beam 15 meter long with a cross section of 400 mm by 400 mm is prestressed with 4 tendons each having 225 mm square area. Is tension to a stress of 1050 Newton per mm square and in successively. Determine the loss of stress in each tendon due to the elastic shortening of concrete. Find also the average percentage loss of stress due to elastic shortening. Take the modular ratio m is equal to 6. Let's sketch the longitudinal and cross sectional view of the beam. Okay, the beam is having 400 mm by 400 mm in cross section. The longitudinal section is like this. So this is the CG of concrete. This is the CG of concrete. Beam is simply supported post tensioned with a 15 meter span. Okay. The beam is subjected to 4 tendons. Tendons having no eccentricity. The first tendon is like this. Okay. The second tendon is like this. Okay. The third tendon is okay, and fourth tendon is like this. So you have to find out the loss due to elastic deformation in each tendon. One tendon is stretched one after another. Okay, the eccentricity of this tendon is 0, exactly at the center of the beam. So elastic deformation loss is calculated. Elastic deformation loss is calculated using this small formula m into fc. Already m is given in question. Okay, how to find out the fc? So fc is equal to stress in concrete at the level of tendon. The tendon is concentric, so the fc is subjected to only p by a term. Okay, so p is equal to pre-stressing force. The pre-stressing force is equal to pre-stress multiplied by area of wire. Okay, so in this problem you are stretching only one cable at one time, so pre-stress is 1050 and you have to put the area of only one wire. Okay, so what is the pre-stressing force? Pre-stressing force is 236.25 kilonewton. So simply you have to put in this formula the fc is equal to 236.25 into 10 raised to 3 divided by 400 mm by 400 mm is the cross sectional dimension of concrete. So the value of fc is the 1.47 Newton per mm square. So this is the value of Fc. So let us discuss the further part of this problem is, so this is the longitudinal section of the beam. Okay, this is first wire, this is second wire, third wire, this is fourth wire. So you are stretching each wire one after another, and you have to find out the loss due to elastic deformation. Elastic deformation loss is calculated using this small formula m into Fc. We know the value of m is directly given in question, and already we have calculated the Fc. It is 1.47 Newton per mm square. When you are stretching the first wire, the elastic deformation loss in first wire is 0. Okay, in first wire it is 0. Next, when you are stretching the second wire, the elastic deformation loss in second wire is 0, but the first wire is subjected to the elastic deformation loss. You have to put +1 here. Okay, when you are stretching the third wire, so loss due to elastic deformation in third wire is 0, but the second wire is subjected to the elastic deformation loss. So you have to put plus here, and after stretching the third wire, the first wire is subjected to the elastic deformation loss twice. Now when you are stretching the fourth wire, so elastic deformation loss in fourth wire is 0. Due to stretching of fourth wire, the third wire is subjected to elastic deformation loss is once. Okay, second wire is subjected to elastic deformation loss twice. Okay, and first wire is subjected to elastic deformation loss thrice. Okay, so then how to find out the elastic deformation loss in each wire? Okay, so loss due to elastic deformation in first wire is m is equal to 6 multiplied by Fc is equal to 1.47, and is simply have to multiply it by 3. Okay, so what is the value? Value is 26.46. 26.46 Newton per mm square megapascal is the elastic deformation loss in first wire. Okay, so elastic deformation loss in second wire is m is 6, Fc is 1.47 multiplied by 2. The elastic deformation loss in second wire is 17.64 megapascal. Okay, so elastic deformation loss in third wire is m is 6, Fc is 47 multiplied by 1. So answer is 8.82 megapascal, and elastic deformation loss in last fourth wire is 0. Okay, then how to find out the average loss? Percentage loss and average loss is different. So first you have to find out the average loss. Okay, So loss in first wire is 26.46, loss in second wire is 17.64, loss in second wire is third wire is 8.82, loss in fourth wire is 0. Divided by 4 you get the average loss. Okay, so 26.46 plus 17.64 plus 8.82, okay, plus 0 divided by 4. So this is your average loss, 13.23 megapascal is average loss. So finally percentage average loss is, total loss is 13.23, initial prestige is 1050 multiplied by 100. So 13.23 divided by 1050 multiplied by 100, so it is 1.26 percentage loss, average percentage loss. This is the completion of this problem.